7.1 Polynomial Functions. First of all, I'm going to start you with some terminology. This is something we've been doing. Just going to talk about a little bit more descending order. That's just putting your exponents in decreasing order. So like x cubed, x squared, then x, then a number. And I'm going to get you to practice this in just a second, so I'm going to go over it and then we'll do it. Next thing, leading coefficient. That's the first coefficient. It's always in front of your largest power. Coefficient's the big number in front of x. Okay, whatever's in front, leading coefficient. And then degree is the highest power in a polynomial. Okay, so all those are going to be important words for this next section. And let's practice it a little bit. So write the following in descending order. All right, well, we need to look for our biggest power. Looks like x to the fourth. So everything that's with that goes with the x to the fourth just comes on down, negative and 3. All right, next we have 2x cubed. Then we have plus 7x squared. Then plus 8x, then plus 19. Okay. What's the leading coefficient? Well, it's the thing up front, negative 3. What's the degree? That's the highest power, so it's 4. Okay, now all this stuff's going to have a part in the rest of the chapter, so get familiar with these terms. All right, first thing, graphs. Just a random graph here. We need to talk about a couple things: end behavior, the number of zeros, and the degree that we've also already kind of mentioned. So if I have just this graph, I'm not going to give a function for it. It really doesn't matter. Just looking at this graph, this shape. Let's talk about end behavior. Okay, what happens as x approaches infinity? Okay, in other words, if I'm going along the x-axis this way, that's going to be going toward infinity. Okay, as I take bigger and bigger x values, I'm heading toward infinity. What happens to y? Okay, well, the further you go to the right, the more y goes up. If it's going up, it's heading toward infinity. Okay, simple as that. The other way is x goes to negative infinity. That's going the other direction. To put it simpler, what happens is x goes right, what happens is x goes left. I guess that's probably a better way to think about it. Well, as x goes left, we're going down toward negative infinity. And that's how you answer those. Okay. So this is an up-down question. The domain part is a right-left question. Okay. Instead of saying right or left, we say infinity or negative infinity. Instead of saying up or down, we say infinity, negative infinity. That's how you have to answer them. Okay. Number of zeros. Okay. Well, chapter 6, we made a big deal out of solutions, zeros, and roots. We have 1, 2, 3 zeros. Okay. Possibly more, but we'll get into all that. Right now, we know we have 3 zeros. Okay. Well, what that tells me is the degree is 3. Okay. So a big thing you want to learn from this section is the degree tells you how many zeros you have. That'll help you a lot as we get into more complicated problems, so you'll know exactly how many answers you should have. All right, so moving on. Then they're going to get into this stuff, plugging or number into a function. This first example and some of the first ones on your homework will seem so easy, it's almost ridiculous. Yeah, you're taking negative 2 and plugging it in for x. That's all you're doing, just like you did back in Algebra 1. So I really won't spend much time on this. Negative 2 squared is 4. Don't let your calculator lie to you. So f of negative 2 equals 11. Now let me give you a new take on this. You may or may not have learned this in Algebra 1. A lot of students want to treat f as a variable and solve for it and start dividing. Well, that's not exactly what's going on here. What's going on is we have a graph, a function. Another thing maybe I should point out at this point is that f of x is the same thing as y. Okay. You've dealt with y equals a lot, and now you're going to start dealing with f of x. F of x is getting you closer to working with calculus, for lack of a better way to tell you why you're doing that. As a math person, it is much more useful than y equals. You probably won't see that, the reason why at this point, but I'm going to start getting you familiar with it, because as you get deeper in math, you'll start to see why. We rather use f of x than we would y. So what you need to know is this can be put on a graph, y equals, you should know that's a parabola at this point because of x squared. And what it comes down to is this was an x value, this was a y value. So at -2, +11, I'm just going to label those points. Basically -2, +11 is a point on your graph. That's what that means. If we did this for every x value that existed, we would get the entire graph. We would see that it is a parabola. And that's the idea. That's what we're doing functions. Okay, so another example, slightly more complicated example. Let's find f of 2a. Okay. This will seem a little different. It's not too bad. You are plugging 2a in for x. It's substitution, just like you did at the end of chapter 6. So everywhere you have an x over here, you're going to put a 2a in its place. So 2a gets squared because it replaces x, substituted in. Okay, so square that, 4a squared plus 7. So f of 2a is 4a squared plus 7. And that's as far as we can go. We can't really do much more. Actually, we can't do anything more. Now, trying to picture 2a as an x value and 4a squared plus 7 as a y value, that's starting to be a little bit of a stretch. Okay, but if you understand the graph from example 1, and we'll throw it back up here real quick, that's the idea. Now we're getting more theoretical. So that's just where we're going. All right, one more example. Find 3f of 4a for f of x equals x squared plus 7. All right, so I'm going to ignore the 3 for right now, putting 4a in for x. So over here, 4a goes in parentheses, it's squared, it's plus 7. And now I need to talk about 3. Okay. Well, it's 3 times f. So that means we're going to multiply everything by 3. And whatever you do on one side, do it to the other. I'm going to put some big brackets around it so I know to do everything inside of here first, then multiply by 3. Okay? So on the left, it'll always come down as 3f of 4a. Whatever you started with is what you'll have on the left. And we just need to do what's in the brackets here. So 3 bracket 16a squared plus 7. Okay, this will stay the same. It's going to come on down. 3 times 16 is 48. A squared stays the same. And plus 21. Okay, so 3f of 4a equals 48a squared plus 21. So it doesn't make much sense what that would look like on a graph at this point, but that's how you do it.